All right, so today we're going to review for the Chapter 9 Quiz 2, which was about determining whether or not functions are invertible, finding inverse functions, graphing the function and its inverse, as well as determining and writing direct, inverse, joint, and combination variations. So we're going to start out with just determining whether or not a set of points is invertible. So when we look at these set of points, if I want to know if it's invertible, remember the idea is there has to be no repeating x's or y's. So when I look at this first one, my x's are 2, 6, 9, and 10. So that's good because there are no repeating x's. Then I look at the y's, which are negative 10, 8, 2, and negative 8. And there were no repeating x's and no repeating y's, so that tells me that yes, this is invertible. And it asks me if it is invertible to find the inverse. Well, remember, in order to find the inverse, all you really need to do are switch your x's and y's. So, since in my original point it was 2, negative 10, my new inverted point is negative 10, 2. And then we keep doing that for every point in the set. Okay, now looking at the next one. My x's are negative 9, negative 6, 2, and 3, which means my x's are good. Now let's look at our y's, which are 4, 7, and then 4 again. So when I look at this, my 4 occurs twice, which means it is not invertible. Now, when we go to look at a graph of a function, remember it is a function if it passes the vertical line test, but it's invertible if it passes the horizontal line test. All right, so it has to be a function to begin with to invert it. So we look and we see, okay, if I drew a bunch of vertical lines, yes, it would only touch each one once. And then I'd need to go and do that with horizontal lines, and every horizontal line that I draw only touches it once as well. So this one, yes, is invertible. But as soon as I look over at problem number 4, I notice that if I were to draw a horizontal line through almost any place on this graph, it would touch the graph more than once, which tells me right away that this one is not invertible. Okay. In the next one, they're telling us, yes, these are functions that can be inverted, so we need to invert them. In order to invert them, remember, we're starting out with the idea that r of x is y, right? And then we can just rewrite the rest of this as the 4th root of x minus 8. Now, in order to invert it, just like when we inverted it with the points, we switched our x and our y. We switch our x and our y when we invert an equation as well. And now our goal really is to get y alone. So in order to get y alone, my first step would be to get rid of that 4th root. And the opposite of taking the 4th root is raising everything on each side to the 4th power. So we would have x to the 4th equals, the 4th root cancels out the 4th power, giving me y minus 8. Then to get y alone, we would have to add 8 to both sides. So we would have x to the 4th plus 8 equals y. And then remember, we need to write it in inverse notation. So r, the inverse of r of x equals x to the 4th plus 8. Now here, you need to be really careful and remember, anytime you end up with an even root means you have to put a constraint on it. So what we do is we take whatever was raised to the 4th power, which in this, or the even power, which in this case was just x, and we set that greater than or equal to 0. So my final answer actually is the inverse of r of x is equal to x to the 4th plus 8 for x greater than or equal to 0. If you forget to put the constraint on it, then that would be incorrect because it would be a function that would have not been able to be inverted. All right, looking at number 6, same basic steps, right? So we're going to start out by putting y in for v of x. And then we're going to go ahead and we're going to put wherever we see a y, we put an x. And wherever we see an x, we put a y. So now we need to get the y by itself, but the problem is there's two y's and my y is a fraction. So we got to take one thing at a time. So let's get rid of the fraction by getting rid of y plus 7 on the denominator, which means we're multiplying by y plus 7. So that this cancels out, giving me 4y plus 2. Then on the other side, we're multiplying these, right? So x times y is xy. X times 7 is plus 7x. Well, now when I look at this, the issue is that my y's are on two different sides. So I need to get all of my y's together. So I'm going to do that by subtracting 4y to the other side. So that we have xy minus 4y plus 7x equals 2. Now, I only want terms that have y in it. So these ones are good for us to keep because they both have a y. But I need to get rid of that 7x. And in order to get rid of that 7x, we would subtract 7x. So now I have xy minus 4y equals negative 7x plus 2. And since both of those terms have a y in it, we can actually just get a single y by factoring it out. And that's our goal. We need to get one y so that we can get that single y by itself. So now I'm going to factor out that y. So y times x would have given me xy. Y times negative 4 would have given me negative 4yx equals negative 7x plus 2. And now, in order to get this y by itself, I have to get rid of this x plus 4. In order to get, the x minus 4. In order to get rid of this x minus 4, remember it's multiplication between these things. So if I just divide by x minus 4 on both sides, then my x minus 4 will cancel out, leaving me with y equals negative 7x plus 2 over x minus 4. And then we have to write it in the inverse function notation for our final answer. And always double check at the end to see if there's any even exponents. If there's an even exponent, I'll need to write a constraint. Since there are no even exponents, I'm done. I don't even have to worry about the constraint. All right, so now let's look at the next page where we're going to have to find the inverse function and graph it on the same coordinate plane. So we're going to need to get out our graphing calculator so that we can find points, right? So I would start out by actually just taking this original one, creating my XY chart, look at it that it says x has to be greater than or equal to negative 4. So I'll start out at negative 4 and go bigger, which would be like negative 3, negative 2, negative 1, 0, because I like to have at least 5 points. And then I'll get out my graphing calculator, go to the y equals, clear out anything that's there. So then we have x plus 4 squared minus 4. I can graph it so I can get an idea of what my graph should look like and where it should be. And then we're going to go ahead and go to our, now notice there's a constraint, right? Because otherwise this would not be invertible. So in other words, they're telling us x has to be greater than or equal to negative 4, so they're going to cover up this section. So we're only looking at this side of the graph, that way we can invert it. That's why there's a constraint there. So let's go to our table and pick those points. So it said greater than or equal to negative 4. So negative 4, negative 4, negative 3, negative 3, negative 2, 0, negative 1, 5, 0, 12. So now I can go ahead and take those points and graph them. Now I won't be able to graph this one, it'll be off the chart, but that's fine, so we'll just graph what we have. And remember to label that so that we know that that's your original function and not your inverse function. So now we have to graph our inverse function, but before we graph it, we need to actually find that function. So since we're starting out with f of x is equal to x plus 4 squared minus 4, that really is y equals x plus 4 squared minus 4. And then we're going to have to switch our x's and our y's. And then work to get the y by itself. So in this case, we're going to get rid of what's outside of the parentheses first by doing the inverse, which is adding. So we have x plus 4 equals y plus 4 squared. So now we can get rid of that square, right, by taking the square root. So I'm going to square root both sides so that the square root and the square cancels out. So I have y plus 4 equals the square root of x plus 4. Now to get y by itself, we're going to have to subtract that 4, and that subtracting 4 is going to stay on the outside. So we have the square root of x plus 4 on the inside minus 4 on the outside equals y, and then we have to write it in inverse notation. So the inverse of f of x is equal to the square root of x plus 4 minus 4. And again, I ask myself, do I need a constraint? And the answer is no, because it's not, I don't even see any exponents in here. And we only do constraints if there's an even exponent. So I can go to my graphing calculator. The y equals, right, clear it out. And type in the square root of x plus 4, arrow out, minus 4. Graph it to see what it should look like. And then I can go to my table to get my points. Now, don't forget though, even using this table, which I could do, I don't like to use the decimals. So to be honest, I don't even have to worry about looking at that. I can just take my original XY table and switch the points. So negative 4, negative 4, negative 3, negative 3, negative, 0, negative 2. 5, negative 1, and check and see if those are there. So negative 4, negative 4, negative 3, negative 3, sorry, that will adjust. 0, negative 2, and then 5, negative 1 is accurate. So then I can just go ahead and I can plot those points. Negative 4, negative 4, negative 3, negative 3, 0, negative 2, 5, negative 1, and there's my other graph. Oh, and then I need to make sure I label that as my inverse function. All right, so now we're going to move on to the different types of variation. So remember that there's direct, which is multiplying, right, with just one variable. Inverse, which is division, which with just one variable. Joint, which is multiplying with more than one variable. Combined would be multiplication and division, and no variation wouldn't have any of that. So when I look at number 8, it's multiplication, which immediately means direct or joint, but since there's two variables, it's joint. In this case, I see division, which means inverse, but there's also multiplication up here, so this one is combined. This one looks like there's division because it's 3/5, but remember, I'm really just taking a number, 3/5, and multiplying it by h, which is just 1, so that makes it direct because we're multiplying with 1. Here, we're doing division with just 1, which makes it inverse. And lastly, this one, there's no multiplication, there's no division, it's just subtractive, so this one is none. All right, so in the following problem, find the constant of variation, the formula that expresses the relationship between the variables, and the requested value. So we'll start out with the original. X varies directly, which remember means multiplication, with the square root of g. So we can start out with that. X varies directly, so we have our constant k and the square root of g, and inversely with h, so we'll divide by h. Then it tells us what the x, g, and h values are. So we're going to go ahead and we're going to plug that information in. So 3 equals k, square root of 16, over h, which is 12. Now if I were you, since I can take the square root of 16, I would simplify that first. So 3 equals k times the square root of 16 is 4 over 12. And now I can go ahead and work to get that k by itself. So the first thing I do to get k alone is multiply by 12, which would give me 36 equals k times 4. Then we need to get rid of the 4, so we're going to take 36 and divide by 4, which is 9. So I know my k equals 9, and that's the first thing that we asked for. The constant of variation is 9. And then I can put that into my basic setup to get the relationship between the variables. So x equals 9 square root of g over h would be the formula with the constant plugged in. And then my last step here is to find x when g equals 36 and h equals 15. So I don't know x equals 9. Square root of g was 36 over h, which was 15. So I can go ahead and simplify this. So again, my first step would be take the square root. So the square root of 36 is 6. So x equals 9 times 6 over 15. And 9 times 6 is 54 divided by 15. And then you should probably make sure that you can't reduce that, which it actually does reduce. So it becomes 18 over 5. So x equals 18 over 5. Now be sure to go back and look at other problems, because anything that we've done over the past few days, anything since the last quiz, can be on there. So make sure you go back and review.